Okay, so welcome back, and now we're going to do an example of graphing a circle given a polar equation. Okay, so I've got this grid on here, and so what we're going to do is we're going to graph this function. And again, obviously I'm not going to draw perfectly, but again, think of concentric circles around 1, 2, 3, and 4. Okay, and so what we're going to do is we're going to graph this, and a couple of things you could do. You could look at symmetry. So don't forget a lot of the tools that we've already talked about, symmetry. So we could test for symmetry, or you could use the fact that of remembering the behavior, the characteristics of the fact that this is cosine, and you have A cosine theta. We've talked about that, and here A is bigger than 0, okay? But let's talk about symmetry, right? We could test for symmetry. So one of the things we can test for symmetry is we could test to see if it's symmetric with respect to theta equals pi over 2. So we can replace this with negative r and this with negative theta and see if we get the same thing, right? So r, okay, 4 cosine negative theta. Now the fact that cosine is what? Cosine is an even function. So we can use that, and we know that cosine of opposite of theta is equal to cosine theta. So if we put in negative r, well, what's going to happen is cosine of negative theta is just going to be the same as cosine theta, and so we get 4 cosine theta. Now, then this does not look like this, so it didn't work. We failed. But that gives me an idea, though. But I now know that this is going to be symmetric with respect to the polar axis, and you might be wondering, well, why? How can I do that? Well, because, remember, to test whether it's symmetric with respect to the polar axis, all you have to do is one of the 2 points to replace it with is positive r and negative theta. Well, in this case, I replaced it with negative r and negative theta. So if I just make this positive, right, and just leave it alone, well, guess what? Now I get the result because all I did was replace this with negative theta and use the fact that this is an even function, and I get the same thing, and now I ended up with the same result. I got back to where I started from. So this tells me that this is symmetric with respect to the polar axis, which is the x-axis, right? Okay, so that's good. Now, the fact that A is positive tells me that I am on the right side. So remember, the characteristics of this is that, hey, I'm going to be on the right side of here. Okay? Also, I can look at the zeros, right? So where is this 0? So I know it's symmetric with respect to the polar axis now. What about the zeros? Where are the zeros? So the zeros will occur wherever r is 0. Okay? So, well, that's going to happen when this is 0. When is cosine 0? At pi over 2, right? And all multiples of, well, let me rephrase that. So it's going to get pi over 2, and then then adding or subtracting all multiples of pi. Okay? So that means that I'm going to have a 0. So if we're looking at zeros, that's going to happen when theta is equal to pi over 2 plus or minus pi times k, where k is an integer. So all integer multiples of pi that I'm adding or subtracting. Okay, so that means at pi over 2, this is going to be 0. So at 90 degrees, this is going to be at 0. Okay? So that means 0 comma pi over 2 is going to be a 0, for example. Okay, what else? Where are the maximum values? So where is this maximized? Where's the radius maximized? Well, again, the biggest that this cosine function will be is 1. And that happens at 0 and what? All adding or subtracting all multiples of 2 pi. So that means the maximum value, okay, the maximum of r is going to be at 4, right? And so that's going to happen at what? When theta is 0 plus or minus 2 pi k. Okay? What else? So what do we know so far? So at 0, it's 4. So what do we know? So we start at 4, so we know at 0 it's 4. So when theta is 0, it's 4, and then it goes from 0 to pi over 2, so 0 to 90 degrees. So as this goes from 0 to 90 degrees, what's going on? Well, eventually it goes to 0, right? So this is where we're gonna, now we have an idea, this is where we're gonna start plotting some points. Okay? And the key point is going to be 4 comma 0, the maximum point. And it goes from 4 and eventually is decreasing because by the time it gets to 90 degrees, the radius is going to be at 0. So it's going from here, it's decreasing as we get to 0. So let's plot this thing. Okay, so we've got a 0 at 0 and a half, so that's what we've gotten so far. Okay, so I'm assuming you're writing all this down. Okay, now let's create the table with our common values. So we have theta and r. And so we're going to go 0, and of course we're going to deal with our common unit circle, right? So we got 0, and then we've got pi over 6, and then we've got pi over 4, and then we've got pi over 3, right? And let's continue our table over here. So we got theta r. And then at pi over 3, then we get pi over 2. There's our pi over 2. And from there we get what? Pi over 3, or excuse me, I'm sorry, 2 pi over 3. So we get 2 pi over 3. And then we get 5 pi over 6 is the next one. And then we got pi is the last one. So let's go with this one. So now 0, we already know, at 0, r is 4, right? That was our maximum value. Then what happens at pi over 6? Well, pi over 6 is 30 degrees. What's the cosine of 30 degrees? That's going to be what? It's going to be square root of 3, right? It's going to be square root of 3 over 2 times 4. So this is going to be 4 times the square root of 3 over 2. Okay? Or, in other words, 2 root 3. Okay, now what about 45, what about pi over 4 or 45 degree angle? What's the cosine of 45 degree angle? That's square root of 2 over 2, so that's going to be 4 times 2 root 2, or just 2 root 2, right? So this is going to cancel, right? All I'm doing is plugging it in here and then I'm multiplying by 4, right? And then pi over 3 is 60 degrees. So the cosine of 60 degrees is 1/2. Okay, and so that's going to give us 1/2 of 4, which is 2. And then the cosine of 90 degrees is 0. So that's going to give us a 0. So notice how we went from 4, then to this, then to this. So obviously it's decreasing, right? Because square root of 3 is greater than the square root of 4. So it's decreasing. Then we go to 2 because this is slightly bigger than 1. So this is going to be slightly bigger than 2. So this is going to 2. So it's decreasing. And then we go to 0. At 90 degrees, it's 0. So now what happens here? Now we went from 0. Now what happens? Now at 2 pi over 3, which has a reference angle of 60 degrees. Okay? But is in the second quadrant. Okay? So in the second quadrant, it's going to have a radius of negative. Negative what? Well, the cosine of 60 degrees is negative 1/2. So this is going to be negative 2. Because again, it's negative because it's in the second quadrant. And this is also in the second quadrant. So this is going to be negative what? Negative, well now we're in a, oops, did I skip one? No, this should be a 45 degree angle. I skipped a 45 degree. This is 3 pi over 4. Hold on. I forgot 45. 3 pi over 4. And then this is going to be 5 pi over 6. And then of course we get pi. Okay, so 3 pi over 4, well that's, again, cosine is negative. Cosine is negative here. So the cosine of 45 degrees is going to be negative 2 root 2. Okay? And then, of course, this is going to be the opposite of this one, right? So this is going to be negative. Okay? And then, of course, at pi, we're back to 4, right? Well, negative 4. But remember, at 180 degrees, boom, and then negative 4 goes the other direction. So we end up back over here. So remember, these negative radius is, again, we're in the second quadrant. So again, just pay attention to what we're doing here. We're in the second quadrant, but the radius is negative, which means it flips it 180 degrees to go in the other direction, which lands it here in the fourth quadrant for graphing purposes, right? So think about, these are polar coordinates, right? So we're going in a counterclockwise direction, but when the radius turns negative, we're flipping, boom. We're basically rotating 180 degrees the other direction. Okay? So when it says 2 pi over 3, we're at a 60-degree angle, but then the -2, boom, it goes this way. Okay? So what happens here? When we plot these, we're getting something that looks like this. So we're going from +4 in the first quadrant. We're going from +4 to 0. Okay? So in the first quadrant, we're doing something like this. And now we can use symmetry at this point, right? We know it's symmetric with respect to the polar axis. But again, if you notice, it's going the same thing. So now we're in the second quadrant. So this angle is going from 90 degrees to 180 degrees. But again, it's negative radius. So it's going from here, and now it's going back up to -4. So it's going to do that. And that's our sketch. Okay? Not bad. Have a good day.